In this video, I'm going to discuss about the 2D frame analysis. In next video, I'm going to discuss about the design and detailing. So here, I'm just going to take the beam length. Okay, the beam length is equal to, let it be something around 5 meters. So we have to give 2 grid lines, and number of grid lines in y direction is 1. And here the grid spacing in x direction is, say for example, let it be 4 meters. Okay. So I want to give the bay length as 4 meters, and in y direction whatever length we are going to give, it doesn't define that one. So here we are going to have the simple story data. Let the number of floors be 1 and the typical floor height is something around 3.5 meters. Okay. So click on OK, and we are going to get the grid system on the screen. We have to define the properties and these material constants, etc. So we can see the 3D grid here. Okay, in this view. Now let us go for the define material properties. So I'm just going to add a new property. Material type is, region is India, and the material type is concrete here. And let us go for M20 concrete. Click on OK. So click on OK again. So I'm going to add the rebar material also. So just go for the rebar here and just choose the required grade. So I'm going to choose the HYSD steel. So grade 415. Click on OK again. So click on OK to close this window. Just go for define and go for section properties. Go for frame section. I'm going to add the new property and let it be a rectangular property. So I'm just going to give it as B1. I'm going to rename it as B1, and the material used here is M20 grade concrete, and the depth of this section is something around 300 cross 230 mm. Okay. And click on reinforcement. Since I have given the beam section, select the design type as beam, and under rebar material select it as HYSD bar. So if you forgot to create the material also, you can click on this icon and you can recreate the, if you want to create a new material, you can create it here or modify the material. Okay. So let us cancel this as we have created this. So I'm going to change the top cover as 30 and bottom cover as also 30. So click on OK. So one section has been created as B1, and again click on add new property. So just select on this, and I'm going to create the C1. Okay, C1 is indicating the column sections. So material type, again it is M20 grade concrete, and the depth of this section is something around 450 cross. Let us take something like 230. Okay. So modify show rebar and let it be column design, and longitudinal bars material is HYSD 415. So you have to change this all the things, and the clear cover for confinement bars is 40. So let it be like that and click on OK. So click on OK to close this window. So we have created B1 and C1, and let us create the beams and columns here. Okay. So we can either quick create the beams and the columns at a time, or let us see step by step. So click on draw menu here and go for draw beam or column braces. So just go for the quick draw beams and just select the grid line here. Okay. And make sure that you are giving the correct section here. Okay. Under property, just select the required property, let it be B1, and select the object on the screen, grid object on the screen. So you can observe that we got the blue line. Okay, and here we need to indicate the columns. So I'm just going for draw again, go for draw beam or column and go for quick draw columns, and you have to choose the property here, that is C1 property. Just expand it and choose the C1 here and assign it for the joints. Okay, so simply you need to select the joints, or just you can drag to select the joints, and you can see that we have got one 2D frame here. Okay, with one bay. One bay is nothing but we are having one single window or single frame. Okay, now if you want to come out of this command, just go for escape, and if you want to see the solid section, click on the 3D view on this window and go for the extruded view. Just click on this and we got the 3D section here. Okay, and I didn't mention any offsets. It has been taken from center to center directly. And if you wish to change the angle, so just you can select the column and go for assign. You can go for frame. Under this you are going to have the local axis. So as we already seen this, you can change the orientation of the column in case if it is required. Okay, so if it is required you can apply, otherwise no need of changing this one. Okay, so let it be 0 degrees. So 0, and I think I need to select this one because the selection has been gone. So just select this one and give the 0 degrees, apply and OK. Right. So in this way we can change the column orientation whenever required, and you can see that local axis has been assigned here. Okay. Now the next command is we need to assign the loading conditions and support conditions. So let us go for the elevation view. So click on elevation. I want to see from the first grid, that is grid 1. Click on apply and OK. And I want to apply the support conditions. So just you can select the support conditions. Suppose to assign the conditions. Click on assign. Just go for the joint. Click on restraints and select the fixed support from the bottom 4 supports. Click on apply and OK. And we can see that the supports has been assigned here. And the next step is to assign the dead load and live load on the structure. Okay. So let us give some gravity loads, that is like dead load. You can calculate the dead load by using the, dead load, how do we calculate that one? So dead load is nothing but the self weight. Okay. Otherwise, if you want to give some brick weight coming on this beam, so how do we calculate? So if you are taking the 0.23 meter grid brick, so 0.23 into unit length and whatever the height of the floor. Okay, for example, height of the floor above this is 3 meters. Okay, and into unit weight of brick, it would be 19 or 20. I'm just going to take 19 here, and whatever value we are going to get after calculating this, we have to assign the dead load. So here is the calculator. Let us calculate 0.23 into unit weight into floor height into unit weight of the brick. So we got 13.11. Okay, I'm going to assign this as the dead load, and we are going to take 3.5 kilonewtons as the live load. So we are going to assign that on the structure. Okay, so let us go for this one. Click on the beam and just go for assign, and we can go for the frames, and we can go for the, we need to go for the frame loads, and under this click on the distributed load and make sure that you are selecting the correct load pattern here. So let it be dead load, and whatever the loads we are going to assign there, that will be of gravity loads, and change here to absolute distance. Since we are assigning UDL, no need to change anything here. So just go for uniform load at bottom left. Okay, so I'm going to give minus 13.11, whatever the calculated value we got. So no need of minus. So 13.11 kilonewton per meter, and click on apply. We got the UDL on this beam. Okay. Similar way, select the beam again and just go for the live load. I want to give 3.5 kilonewton per meter as the live load. So click on OK, apply and OK. So live load has also been applied here. And on screen, if you want to show the dead load or live load, if you want to change the display, so just click on display and you are going to have the load assigned. Click on frame, and the load pattern is showing here is dead. If you want to change it for live, click on live and click on apply. So yeah, it has been selected on the 3D view. So let us click on this screen, this window, and you can go for display, load assign, and click on frame. So here you can select the required pattern and you can assign the dead load pattern on the screen. Okay. In this way, we can change the load visibility on the screen. And next step is to create the combinations. Okay. We have applied dead load and live load for the structure for this frame. And I want to create the load combination also. We need to define that one. So click on define. And at bottom, from bottom, it is fourth option, load case combinations. Okay, load combination. Click on this. We can add the default code, or we can create a manual code, manual combination also. So I'm going to add a new combo here, and you can just rename it as per your requirement. I'm going to rename it as 1.5 dead load plus live load, DL plus LL, and just you can bracket close. The combination is obviously linearly added. Okay, and yeah, I didn't assign any auto load combination, so I have to add up the loads here. The load 1 is dead load, and the scale factor for that is 1.5 as per IS 875 part 1. So here similarly live load, and this is also 1.5. So for loads you are going to use IS 875. Okay, so click on OK, and the combination has been added. So click on OK. While designing, we can add up this load combination. Okay. Now I want to analyze this structure. So just go for the analyze and check for the model if we have any errors or anything. So you can just select all the things if you want to check for all the joints and frame checkups. No need of shell checkups or other checks here. So what I have selected all. So click on OK and the analysis is been run. The checking is being run. Model has been checked. No messages were generated. Okay, no warning messages were generated. Now I can run this one. So just go for analyze and you can go for run analysis and we need to save this file. So I'm just going to save it as 2D frame. Click on save. So the analysis is being run. So we got this deformed shape here. Okay. And obviously if you want to see the SFD and BMD, already we have seen this one, right? So just you can click on this one, display frame forces, and whatever type of load you want to see or combination you want to see, you can choose from the list, and whatever you want to show on the screen, just select that component, click on apply and OK. So right now I'm showing for this load combination. Okay. So if you want to see the reactions, you can click on this support reactions. Since I have assigned supports for the column, you can see there. So FZ, click on apply and you can see the support reaction. We got it as 66.06. Since it is a symmetrical structure, we got like that. Okay. So if you want to see the MZ also, you can click on MZ and we'll be getting MZ for columns with respect to MX and MY. Okay. Yeah, let me show in 3D view. Okay. So click on this and go for the reactions. So I can select MX and MY. So you can see that 8.26 has been generated as the moment. Okay. So next one, if you want to see in arrow marks, you can see in arrow marks. So if you want to see the tabular format, you can go for tabulated. So it will be shown in small boxes. Okay. In this way, we can see the reactions for dead load. If you want to see the combination, reactions for combination, you can see for the combination. You have to change it here. Okay. So after this, just click on OK. And next thing, if you want to show the SFD, just go for this option. And whatever you want to show there, click on apply and click on OK. So here, let me change it to shear 2 If you want to see any axial force generated, you can see axial force has been generated since we are having the columns. Okay. And if you want to see the values, under display options, just select the second option, show values at controlling stations on the diagram. So click on apply and you can see the values on the screen also. Okay. So if you want to see any torsion developed, so click on torsion, apply. So no torsion is there. Let us go for shear force 3, apply. Sorry, shear 2, click on apply. Okay. So in this way we got the SFD and let us go for the BMD also, moment 3 for the beam and column. Okay. So if you are moving the cursor on the screen on the object, you are going to get the values on that particular position. You can cross check like this also. Okay. So on the screen it will be showing minimum, maximum positive and maximum negative moments and maximum and minimum values on the screen. So in this way we have analyzed the 2D frame by giving the material properties and section properties. We have given the column, we have given the beam, we have generated the loads. So if you want to see that, just go for the load assign frame and let me show the dead load. So apply and OK. Yeah, 3D view has been activated here. Okay. So if you want to show the solid view, you can click on the extruded view here. Okay, since the load has been applied. So you can just toggle the transparency views, or if you want to use the extruded views, you can extrude the views here. Let us come back for this and apply extruded view. Yeah. Like this we can analyze the 2D frame. In next video I'm going to say how to design and see the detailing of beams and column.